I have been a volunteer examiner since 1988, and over that time I've given every exam from novice to extra, including the Morse code test when it was a requirement. I've worked with the ARRL, W5YI, and Laurel Volunteer Examiner Coordinators. I also teach ham radio classes, and what I'm going to show you is something I have recommended in every one of my classes. First, a little background on the test. I know you're probably familiar with this, but a little revision never hurt anybody. The technician test is 35 questions. You must answer 29 of them correctly to pass for 70%, meaning you can miss 9 questions. These questions are taken from a current pool of 422 questions. Each of these questions is multiple choice with 4 possible answers given. Of these 4 possibilities, 1 will be the correct answer. The other 3 are called distractors and range from close but no cigar to ridiculously wrong. About now, you're saying to yourself, there is no way I can memorize 422 answers. Well, you're right. Some people have tried to. But the questions you're given are not as random as you might be thinking. Those 422 questions are divided into 10 sub-elements, T1, T2, T3, and so on. And each of the sub-elements are divided further into question groups. So you have T1A, T1B, T1C. Each of those contains anywhere from 11 to 16 questions. All right? Now, for example, sub-element T2 deals with operating procedures. That sub-element is divided into 3 groups of questions that deal with operating procedure topics. Sub-element T6 deals with electrical components, circuit diagrams, component functions, and it is divided into 4 groups of questions. The other sub-elements are very, very similar. So, to summarize, the 422 question test pool is divided into 10 sub-elements, which are then divided into 35 groups of questions. You see where this is going? Your test will consist of 1 question from each of these question groups. Because these groups of questions within the different sub-elements are grouped by topics, many of them are similar questions, asking the same thing a different way, or focusing on different ways of looking at the same principle. Now, I'm going to show you how to create a quick cheat tool. This will help answer, or at least narrow down, the possible answers. So you might get it down to two answers and then think about it a little bit more. Even then, you've gone from a 25% chance to a 55% chance on just a random guess. You'll have a much better chance anyways of walking away from the test waiting for your new call to show up in the ULS. And by the way, that only takes a couple of days. Now, you're only allowed to bring several items with you during the test. The first is a blank sheet of paper. The second is 2 number 2 pencils. Make sure they're sharpened. The third is a simple calculator, not a scientific programmable one. Any cheap calculator will work. I think this one was about $5. The VE test team may or may not provide some or all of these for your use. You know, it's out of their pocket, so be nice. They'll let you know what to bring when you sign up for the test. A quick trip to your local Wally World will see you with all of these at a total cost of way under $10. Or you could just look through your junk drawer. You never know what you'll find in there. Now, before your test starts, your paper must be blank. But there is nothing that limits what can be on that paper after the test starts. So, here's what you should take the first 2 minutes of your test time to do. So, the test has started. You pick up your blank sheet of paper. First thing I want you to do with that blank sheet of paper is take one of your number 2 pencils, not a whiteboard and a whiteboard marker, but number 2 pencil, because I'm simulating here. I want you to draw 3 circles across the top of that paper. Then I want you to draw a line through the middle of each one, like so. And finally, I want you to draw another line from there down. Now, the first one represents Ohm's law. We'll talk about that in just a second, but just know that it's Ohm's law. So, that tells us that voltage is equal to resistance times current. So, put a V up here for voltage. Now, if you're looking at an engineering drawing or talking to engineers, they're going to say that should be an E. All the questions talk about voltage. They don't talk about energy. So, put a V up there to remind yourself. Resistance is the R, current is the I. And you can think of that as a stream. It's just draw an I. The next one is the power equation. So, we're going to have our power in watts, and that is equal to voltage, RV, times the current. Okay, and by the way, this voltage can be the same as that voltage. A lot of times these work together, and you'll have to solve for one, for like this voltage, and you only know the power and the current. So if you know the power and the current, you can figure the voltage, put it in here, then you can figure out what the resistance is because you have the current. The last one, I want you to put a 300 here, and then I want you to put the words WL for wavelength. Again, the engineers will be real sticklers about this and say, no. You have to use the right terms. You have to use E for V, and you have to use the Greek letter lambda for wavelength. Well, if I say lambda, that's fine. I'm an engineer. I know what everybody's talking about, but you might not. So they talk about wavelength in here, and then I want you to put an F here for frequency. Now, why 300? That is because the speed of light is 300 million meters per second. The frequency is going to be put in megahertz. Mega means million. So if I say I'm on the 14 megahertz, I'm on 14 megahertz, I'm actually saying I'm switching back and forth all over the place. I'm doing a complete cycle 14 million times per second. So that allows you to cancel out the additional zeros. Go back to your elementary school division homework, and you'll see where you did it there. Now, I'm going to clean this off, and we're going to blow each one of these up so you can see them better, because I know it's real hard to read, especially if you're on a smaller screen. So, let me put this like this. We're going to make a big circle. We're going to talk about Ohm's law in this one. Okay, so we got our V up here, got our R there, we got our I there. Now, mathematically, these are all related. So, you can say voltage is equal to resistance times current. You could also say voltage is related to current times resistance. You can say resistance is voltage divided by current, and current is voltage divided by resistance. So what you want to do, this is a lot bigger, but you want to cover up, say we're working, the problem is asking, it's giving you these and asking you what the voltage is. So what you do is you cover that up, probably on your paper you just lay your thumb on top of it, you cover that up, and now you find out, look down there and you can see resistance times current. If it's resistance, you cover that up. And now it's voltage divided by current. And current, cover that up, voltage divided by resistance. Works like a champ. Should we try it out? Okay. Let me just jot some numbers down here. Let's say you're working with 20 amps of current and you're working with, we'll come up here and say voltage at 100 volts. So we want to find the resistance, cover that up. 100 divided by 20 is the same as 10 divided by 2. So you got 5 ohms of resistance. All right? Let's clean that off and try solving for something else. Let's solve for voltage next. And I'm picking these numbers off the top of my head, but you will see questions in the test that are very similar. So let's solve for voltage. Now we'll use a kind of a standard thing that you're going to see. Say we have a 50 ohm circuit, 50 ohms of resistance. We are measuring that we are using 2 amps. Okay, 50 times 2 equals, that's right, 100. So we're using 100 volts. Easy peasy, right? Okay, let's go look at the power equation. It uses the same principle, so we won't spend as much time on it. We got our big circle, we cross it down. And you can remember this one because, in a way, it is a pie chart, even though instead of E, we're using V. Okay? So, again, power is equal to current times voltage. Power is equal to voltage times current. Current is equal to power divided by voltage. Voltage is equal to power divided by current. See how all that worked? Great. So let's say we're using 200 watts and we want to find out what the current is. I cover that up. So 200 watts, and let's say we're using 50 volts. Okay? So what's our current? 200 divided by 5, which lose that last zero, you got 20 divided by 5, your current is 4 amps. That will be the answer. No guesses, no nothing. Not close, not estimate. That is the answer if these are your inputs. Let's play a little bit different here. Let me put that back. Play just a tiny bit different. And say we have 100 volts. Over here we have 0.25, in other words, a quarter of an amp, 0.25 amps. What's our power? Okay, so our power is equal to current times voltage. So 100 times 0.25 equals, that's right, 25 watts. Okay. Now if this had been 2 amps, then it would be 100 times 2, which is 200 watts. See how that works? Doing good so far. All right. Next step, we're going to look at that wavelength versus frequency. And a lot of this one doesn't come out exactly right every time. But the question might be, first off, we'll put our 300 up here. We'll put our wavelength here and our frequency here. Remember, the frequency is megahertz, in megahertz. So, now we got this. We're doing fine. And again, wavelength times frequency is going to equal something pretty close to 300. Close enough that you can narrow your answers down. Find the closest one to that. Frequency is equal to 300 divided by the wavelength. And wavelength is 300 divided by the frequency. So let's try that. Let's say our frequency is 7 megahertz. Okay, we want to know what the wavelength is. Now, I know the answer here because I'm a ham, I'm on that band all the time. But so our question is 300 divided by 7, right? After you do the math, you're going to find that is roughly equal to 42, a wavelength of 42. The correct answer that you'll find in the test is 40 meters. The 40 meter band. So, if you got an answer of 42 and everything else is way far away from it, that is probably your answer. Let's try something a little different. Let's go with a wavelength. And let's use the if we have a wavelength of 6 meters, okay, the 6 meter band. What frequency is that? Well, 300 divided by 6 is equal to 50. You buy that? Well, that's the right answer. The 6 meter band is the 50 megahertz band. How about the 2 meter band? Okay, so let's change this to 2. And we'll divide this by 2. Now, 300 divided by 2 is actually 150. The 2 meter band that the hams use is 144 to 148 megahertz. There you go. There's your answer. Easy peasy, right? Okay, one last thing, now that we've got that out of the way, is as you're going through the test, you're going to come across a question that you're just not certain of the answer. Now you could sit there for hours and hours and hours. No, you can't. They won't let you sit there for hours and hours and hours. But you can sit there for a long time trying to figure this thing out, and your brain kind of goes on vapor lock. So what I want you to do at that point is on your paper, jot down that question number. Just over there, it'll be labeled, your questions will be labeled 1 through 35. So if that's question 22, jot down a 22 on there and move on. Clear it. Now you get out to the end, and you're pretty dang confident that you might have made a mistake on 1 or 2, but you can miss 9. You can miss 9. Okay, so go back, try to answer it, do a guess. You got a 25% chance, right? So do your best. Try to make sense out of it. Read it slowly. Read each answer, each possible answer slowly. If you still can't get it, guess it, move on. Because I'll guarantee you, an open hole, you don't fill anything out, it's wrong. So, but anything that you skip, mark it down on your paper so that you then know to go back. Because when you're looking at all those dots, because basically it's a fill in the dot sort of thing, You're looking at all those dots, it's easy to miss one. So the minute you decide that you're going to skip one, go over and take care of it. So, a quick and handy method of answering a few of the questions that they will come up during the test. Now, I put links to the complete technician question pool in the video description, and I've also stuck a link in there to a site where you can take practice tests. Now, speaking of the tech test, I'm currently putting together a tech class using the YouTube videos on this channel. I'll use a lot of shortcuts, a few mnemonics, and some other tips and tricks I've picked up while teaching over the last couple of decades. If you'd like to be notified when the class is posted, please subscribe by clicking on the subscribe bell and ring the notifications bell. If you've learned something during our time together or just enjoyed this, please give me a like by smashing that thumbs up button. Now, I'm sorry, I can't do anything about this face, but every video I make is better than the one before it, and that's saying something. In other words, come back later, they get better. Please share this with anybody who might be considering taking their tech test. And as always, thanks by dropping by my shack for a chat. 7-3 for now. Elmer Tom, ND3N, out.